Okay, so we are now ready to start the exercises on limits of functions. So in this first one, a function is given whose graph is actually given, as you can see in the figure. Based on this graph, we have to say whether each one of these limits exists, and in case it exists, what is its value, and if it does not exist, we have to also provide the reason for that. We have to explain why it does not exist. So let us first look at the graph of G. You can immediately note that the domain of G is the entire set of real numbers. Why? Let us see. On the left side of 1, for any input, we have an output that we can see from this line itself. At the input 1 itself, the output is 0. In other words, G of 1 is equal to 0. In between 1 and 3 also we have values. At the input x equal to 3, the output is 1. That means G of 3 is 1. And on the right side of 3, just like that, we have another straight line. Actually an arrow, one part is bounded and the other part is not bounded. It goes on like that forever. On this side also, this goes down like that forever. So we can see that on the entirety of the real line we have inputs. That means, in other words, the domain of the function G is the set of real numbers. Okay, now let us first of all take this one. So when deciding whether a limit exists or not, say in this one, as x is approaching 1, we have to see what happens to the functional values as we take the input values close to 1. Now if you take the input value close to 1 but on the left side of 1, then you can see that the output value becomes close to 1. And the closer you take the input to 1, always being on the left side of 1, the closer the output value becomes to 1 from the values below 1, that is less than 1. It however reaches 1. That is what I am saying here is that as you bring your x from this side towards 1, your y value goes towards 1. Okay, so it seems like that the limit should be equal to 1. But that's not what happens on the right side of 1. When you bring your x value towards 1 from the right side, the y value decreases and reaches 0. So on these two sides of 1, the values of x, if you make it close to 1, the corresponding values of y do not approach a single number. On the left side it is approaching 1, the output values. On the right side it is approaching 0. So that's why this limit does not exist. And we can of course write the answer like this. The limit of g of x as x tends to 1 does not exist because g of x does not approach a single value as x approaches 1. That is the reason for non-existence of the limit. does not approach a single value, means you can write a single real number as x approaches 1, which you can also write in symbols like this. Okay, so the first limit does not exist. What about the second one? In the second one, x is approaching 2, again from both sides. So this is our 2. So as x approaches 2 from the left side, the y value approaches 1. You can see it like this. As x approaches 2, it goes up, and it reaches 1. And the same thing happens in this case. If you make x approach 2 from the right side, then also the y value approaches 1. So in this case, the limit exists and its value is 1. We just simply write we have, from the graph of course, limit of g of x as x tends to 2 equal to 1. Okay. Then C. What happens in C? In C, the independent variable x is approaching 3. So that means we have to look at the values of the input close to 3. That means either on this side or on this side. And on both sides, when we look and we think of x as moving towards 3, from this side like this or from that side like this, then the y value decreases and reaches 0. So the limit is 0. But note one thing, that at the point x equal to 3 itself, the g value, that is the functional value, is 1. That, however, has actually nothing to do with limit, right? Because when we are calculating this limit, then we want to see what happens near 3, around 3, close to 3, but not at 3 itself. Okay, that should be kept in mind. So that's why in this case the limit exists and is 0. This is equal to 0. So that is the solution. The next few exercises are going to be like this. So let's just go through them one by one so that we can see what else we can have. Again, for the function f of t, for the function f of t graphed here, find the following limits or explain why they do not exist. Okay, so let's first see what the limits are and then we will draw the graph. So this one is limit of f of t as t tends to minus 2. Okay, then part B, limit of f of t as t tends to minus 1, and part C, there is no need to cram the graph here, we will draw it on that side. T tends to 0 f of t. So here we have to look at the behavior of the function f more towards the left of the origin. Now the graph. So in this case, the graph goes like this, towards the left of the origin. Okay, so that means something like this. So this is our x. Oh, we don't have x, we have t. And what is the dependent variable? They are calling it s. Fine. Then now then we need to put the points first. Let me carefully put the points. So this is 1, 0, minus 1, minus 2, minus 3, and on the y-axis also we would need 1, 0, minus 1. Okay, then about these white circles, that figure we don't have now. Let me first draw this one. We already know what the white circles do. They prevent the line or a part of our graph to reach this point around which we draw the white circle. It represents that fact. So on the right side, the graph is this. I am making it quite big so that it can be seen easily. And on the left side, it reaches this point but does not reach this point, and then from there, where does it go? It goes to minus 2. Okay, and then it goes down. Goes down means this. Goes down and it keeps on going, right? Yes. Okay, so this is a point on the graph obviously, and oh, okay, I should not have drawn this part so hastily. Here also we have a white circle, so that means these lines will not reach this point. Okay, anything else? I need to write the numbers. 1, this of course is 0, no need to write that. -1, this is -2, this is 1, this is -1. Is there anything else? So this is of course s is equal to f of t. So that is the graph and these are the limits. So now we have to decide whether each one of them exists or not, and the other things. Okay, so but yes, I forgot one thing, one crucial thing. There is this point also on the graph, the origin. So just like the previous function g, f also has the entire set of real numbers as its domain. Why? How exactly? Am I saying it correctly? Is it really the case? No, that is not the case. Okay. So what I said just now is not entirely correct. One point is missing from the domain, that is -2. When our input is -2, which actually is not an input, no output is specified. So in this case, the domain of the function is the set of real numbers from which -2 has been removed. But the other points we have, and note that although it looks like we do not have any output at 0, at t equal to 0, but at t equal to 0 the output is 0. That is why this single point is also a part of the graph. And the other parts you can of course see more clearly. So let us now see the solution. I hope I have not made any mistake in copying this from the text, but I think there is no output at -2. Okay, so anyway, let's now see the solution. So what is our first limit? The first limit is the limit of the function as t tends to -2. So as you look at the values of t near -2, say on the right side of -2, so as those values approach -2, then the output value approaches 0 from below 0 of course, but it does approach 0 nonetheless. And the same thing happens when your t value approaches -2 from the left side. So that means the limit exists and is 0. We have and this part A emphasizes one point about limit that I was saying there when we were solving the previous exercise, that the limit, its existence, its value, that has nothing to do actually with what is happening at the point towards which the independent variable is approaching. In this case you can see that more clearly because the point -2 is not there in the domain at all. So nothing happens at -2. What happens at -2 is not a part of f. Nothing happens at -2 as far as f is concerned. So that is why, but still we can ask at least what the limit is, and it turns out that the limit exists and its value is 0. Okay, so this particular aspect of limit should never be forgotten, that the limit at some point has nothing to do with what the function is doing at that point, or if it is doing anything at that point at all. In this case, f is not doing anything at -2, but still limit exists, because the limit is all about what is happening around -2, close to -2, but has nothing to do with what happens at that point -2. That's the thing. Okay, so that is part A. Then part B. In part B, it is -1. Okay, now when you vary your t, so this is our point. Now t is approaching -1. If it approaches -1 from the right side, then your f of t value is constantly -1, -1, -1, -1, -1. That's why the graph is horizontal on this side. And so it approaches -1, that is the f of t values. But when you make your t go towards -1 from the left side of -1, then f of t doesn't stay constant, but it decreases. It starts decreasing from 0 and it reaches -1 in the limit. So all the values reach a common value -1, irrespective of which side of -1 you are choosing your independent variability to place. So that is why in this case also the limit exists and the limit is -1. So we just simply write, we have, or if you want to write a little more, you can write, we see from the graph that the limit is this. This is equal to -1. And then we have part C. In case of part C, you can almost see that the limit does not exist, because in part C the independent variable is approaching 0. Now as t approaches 0 from the left side, f of t is constantly -1, -1, -1, -1, like that. It goes on like that. However, when t approaches 0 from the right side, the f of t value, the output value, is constantly 1, 1, 1, 1. So it depends on which side of 0 t lies. I mean, depending on that, what the value of f of t is doing, it depends on that side, which side of 0 t is lying. So that is why in this case not a single value is reached, and so the limit does not exist. And again, what the function f is doing at 0, its value is 0, that has nothing to do with this limit. It has something to do with another thing which we will come to later. Okay, that is called continuity. So for part C we write like this: the limit f of t as t tends to 0 does not exist, because f of t does not approach a single real number as t approaches 0. You can write t approaches 0 in words, or you can write like this. So that is our second exercise. Then the third one. Which of the following statements? Okay, so this next two exercises are again going to be like this. A function will be given, actually its graph will be given, and we will be asked about some limits, but this time some statements about those limits will be given. We have to decide whether those statements are true or false. Which of the following statements about the function, okay, let me write. Which of the following statements about the function y equal to f of x graphed here are true and which are false? Okay, so now we need the graph and then we will write the statements. So again another graph, and this time the domain is not the entire set of real numbers but a small part of it. Okay, so in this case y and x, usual variables. We need -1, so -1, 1 and 2. Okay, -1, 1 and 2, and on the y-axis we will need 1 and -1. This is 1 and this is -1. And what is the graph? Let me first draw the white circles. So this half is like this, and this half, it will one point will be reached and the other one will not be reached. So let me put a black circle here because this point has been reached. It is a part of the graph. And to compensate for this, I mean it is also this x equal to 0 is a point in the domain, but what is the output? The output is 1, a single point here. And we have something else also. At 1, no more white circles. Yeah. So at 1 the function is 0, and at 2 its value is 1. That means this one. and we join them by this straight line segment. So this is basically the graph, and let me write the numbers: 1, 2, -1, 1, -1. And now we write the statements about some limits. There are several of them. A. The first one is this: limit of f of x as x tends to 0 exists. So that is the first one. The second one is that this limit has not only exists but its value is 0. That is the second one. Then part C. Limit of f of x as x tends to 0 is 1. Okay, let me write part D here itself so as to save some space. So you can clearly see that both these two things cannot be simultaneously true, but both can be false. That possibility is there. Then part D is limit of f of x as x tends to 1 is 1. Then part E, that this limit is 0. And part F is a statement which is a little slightly longer, and it's a little general. This limit where x approaches x naught exists at every point x naught in the open interval -1, 1. Okay, so let's see which of the following statements. This part we can just simply erase. At this point, I suddenly remember an advice that was given to me by one of my teachers, is that no matter how trivial or no matter how well versed you are in something, never lose your focus, and always, especially in this kind of things where you have to think logically, always rigorously think about each step, what you are doing, what we are doing, actually why a particular thing is true. Because the moment we lose focus, then we can make mistakes, and that does happen. Trivial mistakes happen, and in some places which looks like the whoever committed that mistake doesn't know about it properly. Okay, so that should not happen. So that is why it's always better to go with these things slowly and not speed up. Of course, sometimes you need to speed up. If you are writing an exam, then you need to speed up. You need to practice in advance how to speed up your writing, how to think fast. But when you are doing mathematics in leisure or something like this, when you are actually trying to learn the thing, always go slow as possible. It may be boring, but it will pay off in the end. Okay, so let's now think of the first one, part A. So the part A says that the limit of f of x as x tends to 0 exists. Okay, let's see what happens when we take x towards 0 by taking x towards 0 from the left side. So as x goes towards 0 from the left side, f of x increases from below the x-axis and reaches the x-axis, or the y value reaches from below and it reaches 0. And the same thing happens on the right side of the y-axis also. That is, when you make x tend to 0 from the right side, then your y value or f of x value also reaches 0. So yes, this limit exists and its value is also 0. So A is true, B is also true. Okay, let me write like this. So because B is true, C is automatically false. Then D. Now what happens to D? Does the limit exist? Here x is approaching 1. So that can happen in two ways, either from the right side of 1 or from the left side of 1. Now as x approaches 1 from the left of 1, the f of x value actually decreases, and in the limit it reaches -1. Whereas when you take x towards 1 from the right side of 1, then your f of x value, again it is decreasing, but it's coming from higher up, and it reaches 0. So they do not reach the same real number. So limit does not exist. So if limit does not exist, then how can it be 1? So here it is false. Have we been asked to write any reason for this? Actually no. So I choose to not write anything else. You can of course write if you want in brackets for your own sake. I mean, it's not asked in the exercise, but you can write why it does not exist, and you can see why. Okay, so I choose to not write this. Then we come to E. Because this is false, not just because the limit is not 1, but the limit does not exist at all. So this is also automatically false. Then part F. I hope I have not messed up this. Yeah, there are 6 of them, right? 1, 2, 3, 4, 5, 6. Yes. Now this one is a little general. When x0 is a real number in this open interval, -1, 1, then what happens to this limit? Say we arbitrarily take one x0. Say we take x0 here. So this is our x0. Then accordingly, the f of x, I mean what I am trying to say is that there is a point on the y-axis corresponding to this x0, and together they give us a point on the graph, this point. Now, as your independent variable x approaches x0 from the left, here also we have to see that left right thing, then your f of x value increases and reaches this, say, let's call it y0. And when you take x from the right side of x0 and make it closer and closer, take it closer and closer to x0, then your y value this time decreases but still reaches y0. That means irrespective of which side we are choosing to put our independent variable x and make it close to x0, the output value is approaching y0. So limit exists, and that limit is y0. Y0 of course is nothing specific, but the point here is that the limit exists. And you can see that it does not matter where we consider this x0 on the left side of the y-axis, as long as we do not touch -1, because we are taking x0 here. And a similar argument tells us that if we take our x0 on the right side of the y-axis and not touching 1, then also the limit exists, whatever it is. Depending on what x0 is, actually the limiting value will be decided. The limiting value here is not, that does not matter. The fact that matters is that the limit exists. And what happens at x equal to 0? At x equal to 0, the limit is 0. We have already seen that. So that means at every point in this open interval, the limit of the function exists. So it is a true statement. Okay, so that is our exercise 3. And let's see one more like this. Exercise 4. Again, the beginning is just like 3. Which of the following statements about the function about the function y? Here also it is f, no? Yes. Graphed here are true and which are false. So now the graph. This graph needs a little more vertical space. Okay, so I hope I have enough y-axis and enough x-axis, or rather enough of y-axis and enough of x-axis. So in this case the points are going to be minus -1, 1, 2, 3, and on the y-axis I will need 3 points, 1, -1, -2. Okay, now there are many black points. Let me first draw the ones that are on the x-axis. These are all, this is blackened but it's not a part of the graph, and there is one more. This one. Okay, and there are 2 white circles. One white circle lies here, and another one lies here. And here parts of the graph are not straight. In fact, the only straight part is this. In the previous graph, I didn't say anything more about the domain of the function. I just simply said that it's not the entire set of real numbers. This is, in this case also, that's the situation. Okay, so on this part, the graph dips like this. It never quite reaches this point, but it keeps on going towards it without any end. My free hand is so bad. Yeah, it got even worse. Let me try once more. Yeah, it won't get any better. You understand what these things mean. And here it's a semicircle, and there I was saying that this 2 is not a, no, it is a part of the graph because this point is not there. So this is a single point, that's a part of the graph. So this is our graph. 1, 2, 3, -1, 1, -1, -2. And now what are the statements about limits? Towards the end of this text, which is far away, I mean this text is so large, there are some pretty involved graphs, 3D graphs. For them, of course, you cannot expect me to draw such things here because my drawing is so bad. So for that we will have to rely on the text itself. Okay, so now the statements. A. Limit of f of x as x approaches 2 does not exist. Part B. This limit exists and has value 2. Okay, so A and B cannot simultaneously be true. Part C. Limit of f of x as x approaches 1 does not exist. Okay, then D. Limit, so D is generally. Limit of the function as x approaches x naught exists at every point x naught in some interval -1, 1. And part E. Exists at every point x naught in, now the interval is 1, 3. Okay, so let's start the solution. I again repeat that this is a semicircle. For it to be a semicircle, if you draw a vertical line at 3, that should be a tangent to this curve at that point. Okay, now the solution. So what happens when x approaches 2? When x approaches 2 from the left, f of x approaches 1 because this is level 1. And the same thing happens when x approaches 2 from the right side. F of x approaches 1. So A is false. B. B is also false because although the limit at x equal to 2 exists, that means this limit exists, its value is not 2, its value is 1. See, this does not. Okay, so what happens at x equal to 1? You can understand that the limit does not exist. The functional values are reaching -2 as x approaches 1 from the left side, and the functional values are reaching 0 as x approaches 1 from the right side. So C is true. Okay, then this general one. Limit of f of x exists at every point in this open interval -1, 1. Keep in mind open interval -1, 1. So that means x naught cannot be taken equal to 1. Okay, x naught cannot be 1. So either x naught lies on this side, and we have already seen in the previous exercise, previous solution, that in that case the limit does exist. In fact, the graph is also exactly the same on that side in the previous exercise. And the same can also be said about the right side of 0, because although the graph here on this side is not a straight line, but it is after all a curve, no, and we won't reach 1. We just need a point here, say. No matter how close that is to 1, it is after all lying to the left of 1. So as your independent variable is approaching that point from the left side of that point, then your dependent variable approaches something here. And also when your independent variable approaches that point from the right side, then the functional values go up and still reaches some point, and that point, that real number of the y-axis is the limit. So yes, D is true. The problematic limit which does not exist, it does not appear here in this region. And finally F. Okay, what about F? Oh, we do not have F, no? We have E. Something is wrong here today because of some incident. Anyway, so this time we have to decide what happens to the limit if our x naught lies in within this open interval 1, 3. You can understand that if your x naught value lies to the left of 2, x naught value lies to the left of 2, not x. Okay, first we choose the point x naught and then see what happens to this limit. Then of course the limit exists. As your x approaches x naught from the left side, your functional value approaches something, and as x approaches x naught from the right side, your functional value decreases and but still reaches that something. So on the left side of 2 the limit exists. Similarly on the right side of 2 also the limit exists. And what happens at 2? At 2 we have already seen that the limit exists, and that is why this is false, which says that the limit does not exist. But the value is not 2, the value is 1, but the point is that limit exists, that particular limit exists. So E is also true. That completes this solution. And I end the video here itself. We are going to continue with more exercises and their solutions from this set of exercises in the next calculus update. And tomorrow, no? What should we do tomorrow? What is the, I seem to have forgotten everything. What is the day today? Is it I think it's Thursday, no? Thursday or Friday, sorry. Oh, so tomorrow is Saturday, so that means one of these three things has to be done. Gallian group, Gallian ring or Lie. Lie we have already done, so that means let us again continue our solutions of Gallian's group theory exercises. So see you with those things tomorrow. Until then, this is me, Lucifer, from a mathematical group. Have a nice night.